Okay, guys, I just want to give you a little bit more detail on some things that you're doing as far as working these identities, verifying identities. Section 5.1 was just a brief introduction to give you some basic identities and how to manipulate them, but Section 5.2 is going to get into more of the heart of what we would be doing in this section. We are going to be verifying Trig identities. Now, I told you what an identity was last time you were in class, but remember you have an equal sign, and you want to verify that one side is indeed equivalent to the other side. And I'm going to start with just some tips for verifying. All right, and the tip number one is if you have not, you need to learn the fundamental identities that we talked about from section 5.1. Okay, if you haven't learned that, guys, you're putting yourself at a great disadvantage. So be sure that you learn that. And on top of that, I might note that you need to recognize the equivalent forms of those identities. For example, you should recognize that 1 minus cosine squared of x is indeed sine squared of x. You know, that's the Pythagorean identity rearranged. So learn those identities. Number 2, you need to try to begin working your problem from the more complicated side. It's going to be easier to take something complicated and simplify it than it is going to be taking a simple something and making it complicated. So try to begin with the more complicated side of your equation. Another tip, and this is one that we looked at in class, is you can try to rewrite your terms in sines and cosines and simplify. Okay, sometimes that helps just to turn everything to sines and cosines and work from that vantage point. Sometimes it just makes life easier. I apologize for coughing, guys. It's just been a horrible cough I can't get rid of. Okay, tip number 4. If there is some algebraic operation that needs to be performed, do that. Any factoring, perform any factoring or algebraic operation expressed. Okay, that will help you get those figured out a little better. Let me give you a quick example. Suppose I had sine squared of x plus 2 sine of x plus 1. Now this may blow some of your minds, but this factors. This is the same as sine of x plus 1 all squared, because this piece is a perfect square and this is a perfect square, and we've doubled those two multiplied together. It's just like if I had something of the form a squared plus 2ab plus b squared, it would factor into a plus b all squared. That's where we're getting it. That's the relation. So, recognize things that can be factored. Another thing that you can do when you have like algebraic operations, things like 1 over sine of theta plus 1 over cosine of theta. This naturally lends itself to getting a common denominator. So do that. So if there are things that seem to naturally appear, go with that. Work on that. Okay. tip number 5. And these again are just tips, guys. They're tools to put in your pocket to pull out and try to use when all else fails. Keep in mind the side you're working toward. This is very critical. In this section, you will have a goal. You will have an objective, where in the last section, you didn't necessarily have that. That makes a phenomenal difference. So keep in mind the side you're working toward. That's your goal. Another tip, if your expression contains something like 1 plus the sine of x, you can multiply both a numerator and the denominator by something like 1 minus sine x. What that's going to result in is 1 minus sine squared of x, which we know as cosine squared of x. Okay, this is what we would consider the conjugate. 1 plus sine of x and 1 minus sine of x are considered maybe conjugates in some realms. No, this is true for 1 minus sine of x, or 1 plus cosine of x, or 1 minus cosine of x. You would just use some of those basic ones, just change the sign to multiply top and bottom by it. And we'll look at some like this to help you know what's going on. But that's a suggestion. And then the last thing that I would suggest or just note for you is that we are verifying that the two sides are equal. We are not assuming this. They may not be equal. Okay, we're verifying that. And because we're verifying that, you cannot treat this like a regular equation, which means you cannot add like terms to both sides of the equation or multiply. You have to work within one side at a time. Okay? You can work on both sides, but you can't move junk from one side to the other or multiply through by a term or divide through by a term because you do not know that these are equivalent. You're verifying that. And so you have to only work within one side at a time. Okay? That's very critical. Very critical. Okay, and those are the 7 tips. So I'm going to work for some problems for you. And remember, I've done this for a long time. It may not come as easy to you, but just hang in there. It's going to be okay. More practice, the better. So I want to verify, first of all, that cotangent of theta plus 1, isn't it equal to cosecant of theta times cosine of theta plus sine of theta? Now, I'm going to start with my more complicated side. In that case, my more complicated side is the right-hand side. All right, so I'm going to keep cotangent of theta plus 1, and I do ask that you keep nice form. I'm going to change the cosecant to 1 over sine of theta. That is by the reciprocal identity. And if you can label your identity as you use it, then you know you're not making stuff up. All right. So now I have cotangent of theta plus 1 equals, and I'm going to multiply this out. So this would be cosine of theta over sine of theta plus this would be sine of theta over sine of theta. That was just multiplication. Sorry, not really. You got it. All right. So now I have cotangent of theta plus 1 equals Well, cosine over sine is cotangent of theta. This is by the quotient identity. And sine of theta over sine of theta is just 1. So now I have my left-hand side equaling my right-hand side, so I'm done. This has verified that these two are equivalent. And notice I just kept working on the right-hand side only, and to make those two sides look equivalent. Excuse me. Okay, let's do another one. That one was fairly straightforward. Let's look at tangent squared of x times 1 plus the cotangent squared of x, all equal to 1 over 1 minus sine squared of x. Well, huh. I might would start with my right hand. No, I guess I'll just start with my left hand side. I'm going to start here, hard to know, and I'm going to change everything to sines and cosines because I'm at a loss at the moment. So tangent squared of x is sine squared of x over cosine squared of x. That's by the quotient identity. And then I have 1 plus cotangent squared of x. Well, cotangent is cosine squared of x over sine squared of x. And I still have my little 1 over 1 minus sine squared of x. Notice I'm holding form. As I change things, I am only changing within the system. I'm keeping everything else the same. Don't lose the side that you're working with, okay? Don't lose it. You need it. Alright, now I'm going to distribute. I think this becomes sine squared of x over cosine squared of x here. And when I multiply these in, I'm going to get 1. I might be undoing what I need to do. Sometimes that happens. Okay, we'll just go with it. Sometimes we go around the world. But I like to think through them as we go. Alright, here's what I know. I'm going to make a connection anyway, even though I'm going around the world. I know that cosine squared of x is the same thing as 1 minus sine squared of x. And the reason I'm putting this here is because I know where I want to go, and I've got to have that 1 minus sine squared x on bottom. This is by the Pythagorean identity. It's just rearranged. So that's one thing you need to recognize, that rearranging of the Pythagorean identity. So now I'm going to get a common denominator. It would be 1 minus sine squared of x. So this first one would stay sine squared of x. That would have me multiplying this top and bottom by 1 minus sine squared of x. So this will become 1 minus sine squared of x, because I got a common denominator. Notice the sine squared of x cancels on top, and it leaves me with 1 minus sine squared of x equal to 1 over 1 minus sine squared of x. So this is done. I've verified it, kind of around the world, but I verified it using just that one-handed side. I hope you are doing all right. Let's do another one. I'm all about just working you some problems. Alright, if I have tangent of theta minus cotangent of theta all over sine of theta cosine of theta, and I want that equal to secant squared of theta minus cosecant squared of theta, I can really go a dozen ways, but I'll start with the left-hand side again. I'm going to break these up. I have tangent of theta over sine theta cosine of theta, and I have cotangent of theta over sine of theta, cosine of theta. Now remember, if this denominator had had a plus sign, I would not be able to break that up. But because it's being multiplied together, sine and cosine, then I can break those up into two pieces. So keep that in mind. Don't perform illegal operations in the process. Alright, now I'm going to switch this. Tangent is sine of theta over cosine of theta. But I already have sine of theta, cosine of theta on bottom. So notice this tangent became sine over cosine. That's where that came from. I'm going to play that game again over here. Cotangent is cosine of theta over sine of theta, but I already have a sine theta, cosine of theta over here. Again, cotangent came into here. That's the quotient identities. Equal to secant squared theta minus cosecant squared of theta. Okay, so now these actually cancel to leave me 1 over cosine squared of theta. These actually cancel to leave me 1 over sine squared of theta. I am getting much closer. This by reciprocal identity is secant squared of theta. This is cosecant squared of theta. And that is exactly where I was trying to get to. So I'm done. I have verified that they are exactly alike. For sake of tip that we had given you, I told you that you might want to look at when you had 1 plus sine of x or 1 minus sine of x, that you might want to multiply top and bottom by that. I'm going to show you that tip right here. I'm going to work on the left-hand side, the right-hand side this time, just for sake of being something different. And while I have 1 plus sine of x over cosine of x, I'm going to multiply this side, only this side, by 1 minus sine of x over 1 minus sine of x. Is that okay? What does this actually equal? This actually just equals 1. And I can multiply anything by 1 all day long. That's not a big deal. Alright, so now I have cosine of x over 1 minus sine of x equal to, on the top I'll get 1 minus sine squared of x, and on the bottom I have cosine of x times 1 minus sine of x. Good. So that was a tip or trick that you had in your list. See in this piece right here, the 1 plus sine of x, they had you multiply by the opposite sign, 1 minus sine of x. Okay, so still cosine of x over 1 minus sine of x. I hope that you recognize that 1 minus sine squared of x is actually Pythagorean in form. It's cosine squared of x. And then those cosines go neatly away. Well, reduce. Cosine goes into here 1 time. So I have a cosine of x on top and a 1 minus sine of x on bottom, and I'm done. Woohoo! Alright, let's consider one more problem and then we're going to call a little break here on this video. But this problem is actually going to be worked from both sides, and that does happen sometimes when things just get a little hairy. We sometimes work through these on both sides to get to the same point. And that's not a big deal. Okay. Well, on my left-hand side, I would be very tempted to change all of that to sines and cosines. Alright, so over here, I'm going to change that to 1 over cosine of theta minus sine of theta over cosine of theta. This was by the reciprocal. The first one was by reciprocal. The second one was by quotient. Over 1 over cosine of theta I'm sorry, that should be a plus on top, forgive me, minus sine of theta over cosine of theta. So again, that top plus should remain a plus, and that bottom minus should remain a minus. I hope that that did not confuse you guys too much. While I'm looking at this, I notice that this top is factorable. This breaks into 1 plus sine of theta times 1 plus sine of theta. Or some people might write that as 1 plus sine squared of theta. All right. Back on the left-hand side, I'm going to get that common denominator. I have cosine of theta over. On the top, I have 1 plus sine of theta. On the bottom, I have 1 minus sine of theta. All of those over cosines. I said theta, I mean alpha. And you know what? Cosine squared of theta, we'll have a cosine squared of theta, so we'll go with that. We'll see how that pans out. Alright, on the left-hand side, I'm going to divide these fractions. Remember, that's by flipping and multiplying. I have 1 plus sine of theta over cosine of theta times, that'll be cosine of alpha. I'm going to get that in a minute. And 1 minus sine of alpha. I'm just flipping those fractions and multiplying. Oh, guys, it's getting bad. Okay, sorry. Don't forget your cosine squared. Alright, I guess I am going to go do what I thought I was going to do to start with. I have 1 plus sine of alpha on top, 1 plus sine of alpha on top, and on bottom I'm going to change that cosine squared to 1 minus sine squared. Okay, it's just where I need to go. That's the Pythagorean identity that I'm doing that by. The cosines go out, and I'm left with 1 plus sine of alpha over 1 minus sine of alpha. Here I've got my 1 plus sine of alpha on top, and I have 2 of them. On bottom, this is a difference of squares. It breaks into 1 plus sine of alpha and 1 minus sine of alpha. And notice that's good for us because these guys cancel. And I'm left with 1 plus sine of alpha on the left-hand side over 1 minus sine of alpha. And on the right hand, 1 plus sine of alpha over 1 minus sine of alpha. So there we were, working two sides, still coming to an agreement at the end. Alright guys, 5-2 will not get any easier unless you really work hard at working problems. I hope this video has helped, and we will definitely talk more about this in class come Monday.